Hello guys, welcome back to my channel. In this video, I'm going to take you through the number system conversion, and we are going to start with the octal to binary conversion. If you have watched my previous video, you will find that I have done other conversions. For example, I had already done the octal to decimal, and I had also done the binary to hexadecimal and also the binary to octal conversion. So for this particular one, I'm going to take you through on how to convert an octal to a binary. And these are the steps. You write down the number, you obtain the binary equivalent of each digit, and you write it in 3 bits below the digits. And lastly, you combine the binary number and you write the answer in the base 2. Okay, before we move to the actual example, you need also to remember that for the decimal, for the binary, it must have 2 number, because if you look at by means 2, and the numbers are either 0 or 1. While for the octal, it's a number system that is made up of 8 different digits. That is from 0, 1, 2, 3, 4, 5, 6, and 7. So whenever you convert a number from octal to binary, the binary will always have a base 2, because the number of digits that are in the binary number system is 2. Okay, let's move to the actual example where we have, let me expand this one. So this is my example where we have 41 base 8. So this is an octal number and we need to convert it to a binary number. Remember the rules. This is my conversion table, so you need to be conversant with this one. For number 0, it's supposed to have in the binary 3 zeros. For 1, it's 1 1 0 0 1, 2 0 1 0, 3 0 1 1, 4 1 0 0, 5 1 0 1, 6 1 1 6 0, 7 1 1 1. Remember, we had said that the number of octal number that we have from number 1 to number 7. While for the binary, we have only 2, that is 0 and 1. By means 2. So for this one, remember the steps, the procedure. So you write down the number, and our number is so my number is 4 4 1. Step 2, you obtain the binary equivalent of each digits and you write it in 3 bits below the digits. For the 1, as you can see, it has, for 1, it has 0 0 1. While for the 4 has 1 0 0. Okay, having done that, the next step is to combine the binary numbers and you write the answer in base. It's a very straight thing. So you will have 1 0 0 0 0 1. So what we have done, we have combined the 2 digits, then you write the answer in the base 2. So this is base 2. And that is the answer. The answer is 1 0 0 0 1. So this is correct. This is a good work. I hope up to that point we are together. Okay, let's move to the next part. Our number example 2, we have 5 3 6 8 base 8. I will give you maybe 2 seconds. Maybe you can give it a trial, then you can do it together. So remember the rules. You write down the number, you obtain the binary equivalent of each digits in 3 bits below the digits, and lastly you combine the binary number and write the answer in base 2. That is the best way to convert your octal to binary. Okay. Okay. So 1 minute remaining. That is seconds remaining. Okay, let me do it now. So my number is 5, 3, 6. So from the table, you can see that the value for 6 for the 6 is supposed to be 110. This is 110. While for the 3, it's a 011. While for the 5, as you can see, it's supposed to be 101. This one, we have this one, we have this one, and we have this one. Okay, the next step is to combine the digits. So we have 0, 0, 1, 0, 1, 1, 1, 1, 0. Then we have base 2. And that is our answer. Our answer is 1, 0, 1, 0, 1, 1, 1, 0 base 2. So this is correct. Okay, let's move to our next example where we have a number which has two parts. It has the fractional part and it has the integral part. Remember, the integral part is the number that is supposed to be on the left hand side, where the fractional is the number that is after the point, which is on the right hand side. Okay, so what you are going to do on this one, the steps are the same. The only thing that you are supposed to do is maybe to separate the point. You just separate the point. So you write down the number. Maybe I should give you maybe some few minutes. You go through the whole. Maybe should I give you around? Let me give you 3 minutes to go through the thing. Okay, I hope that you have attempted the whole thing. So let me go through the whole thing. So my number is 1, 4. Then we have a point. There is a then the number is 1, 4 point 4. And for the 1, it's supposed to be 0, as you can see from the table, 0, 1. For the 4, it's supposed to be 1, 0, 0. Then we have a point. Then there's a point there. Then for the 4, we have 100. So the next step is to combine the numbers. That is 0, 0, 1, 1, 0, 0. Then there is a point, 1, 0, 0. Okay, therefore the final answer should be 0, 0. Sorry. Let me correct this one. It's supposed to be, remember, for the binary, you ignore the zeros that are, you ignore these two zeros, this one, when you're writing the final answer. So the final answer will be 1, 1, 0, 0, point 0, point 1, 0, 0. Then the base 2. So that is the answer to that particular question. I hope now you have learned something through the whole thing. It's a very simple concept as long as you are able now to interpret the step that you're supposed to take for you to reach the final answer. But the most important part on the binary to octal to binary conversion, you need to get yourself conversant with this table of conversion where we have the octal and the binary. Okay, maybe I should give you something small to practice with. Maybe you can try to get the value of 6. So you get the value of 6. So for the value of 6, the answer will be definitely, you write down the number. So the number is 110. Therefore, the answer will be 110 base 2. So thank you for taking time to watch. I know that you have learned something on the octal to binary conversion. So in order to continue supporting the channel, don't forget to like and don't also subscribe. In case you have any question or any suggestion, kindly write it down in the comment section. I will get back to you as soon as I see your question or suggestion. Thank you and bye bye.